Hello, and thank you for watching this video. My name is Ryan Bolden. I'll be giving a brief introduction before handing it over to my colleague Dimitri, who will be providing a demonstration of the InfoCDC and AS400 gateway for Kafka. In this demonstration, new orders will be created in the master IBMI DB2 table, where each order will be given an order name and quantity. Once each order is created, the InfoCDC will pick up new orders and stream them into a data queue, which will then transfer them to the Kafka source connector. After being processed by Kafka, the sync connector will stream them to their final destination, which in this scenario will be MySQL tables. Next, I'll be passing it on to Dimitri, who will be starting the demo portion of this video.
Thanks, Ryan. In this demo, guys, we are going to show how using InfoCDC product and Kafka Connect configuration, we can define our data replication pipeline without any coding required, just the configuration. So this is a simplified use case, of course, but it's fairly representative of what many of our customers are trying to achieve, where the core system of record application running on IBMI system needs to replicate some data in real time, whether for analytics or to offload some read-only transactions from their backend systems to intermediate cloud-based databases, or just to notify other systems of change events. So in this case, for example, we want to capture the changes to our order management system and stream them in real time to MySQL database running on AWS platform. So first, let me walk through the screen. This is our dummy ERP system or order management system. As you can see, for this customer, we have 6 orders already created, which matches the orders in our MySQL for that same table. And as you can see that the latest order is 15110, and that matches what we have in our ERP. So let's go ahead and create a new order. And, so we're going to press F10 to create a new order, and that should result in new order details immediately visible in our cloud database. F10, and then rerunning this query. As you can see that there is another record created, 15111, and that's exactly the order number that we just created. So it worked great. Now let's test the order status update. And actually, before doing that, let me jump into InfoCDC configuration and show how the change data capture is defined on IBMI end. So this is the configuration view of InfoCDC product. And don't be scared by too many tables or busy view. It's just something that we used for our internal testing. But for this demo, there are 3 relevant tables that we defined in this product. It's order header, details, and customer master. So for example, for order header, into detailed configuration. And here, as you can see, we capture the insert, update, and delete events. The product allows you to select all 3 or just a subset of events. It will automatically sense the structure of the columns and bring in the types, lengths, and sequence of the columns, as well as the unique keys identified within DB2 database. And here you can choose to replicate all columns and select all kinds of changes, or just filter on specific columns. This would be very useful for customers running on older systems that were designed quite some time ago, where designers tend to favor the denormalized data models, where, for example, the same customer table might have information about customer, account balances, customer biographical information, everything on a single line, resulting in a huge, very long record format. So if, for example, CRM system only is interested in customer name and address changes and doesn't care about any financial information, you could only select a subset of fields to watch for and replicate. So that could greatly reduce the number of chatter between your IBMI system and external systems. So let's take a look at the change event. Going back to our order management system, let's change the order status from booked to, say, picked. Press enter. Rerun the selection here. And as you can see, the record for 15.111 now shows order status of picked. So it worked. Magic. Fantastic. Yeah, demos are not always that lucky. So that is the IBMI side. As you can see, it's fairly straightforward. You just define your conditions. You define the table, columns, which columns we need to listen for changes for, and which columns do we need to send out for replication. And that's pretty much it. The product automatically creates a data queue where the change will be streamed to, as well as the format file that represents the structure of that message, includes the columns we need and some additional metadata. Now, switching over to InfoCDC, Kafka Connect configuration for this. Again, Kafka demo that we created is probably a simplified approach, where we just have standard Kafka topics and two sets of connectors. Number of sources that listen for data queue messages, and then sync connectors that apply those changes to target database. So if we take one of the source configurations, go through this. We point to our IBMI environment. We provide user ID and password. It's all can be parameterized, of course. The connector does support TLS configuration, where you can define your certificates in trust store and reference in the connector. It supports both keyed and non-keyed data queues and provides some other controls over timeouts, reconnections, and other behavior of the connector. It does require a license, and you can define license location either on each local environment or somewhere in the shared network or cloud storage. And then the main thing here is to point to the actual data queue to listen to, specify the format file that gives this message a structure and types, and provide a target Kafka topic where that message should be placed. And that's pretty much it. So that's a very simple configuration for the data queue source. Basically, you just point Kafka Connect to continuously listen for new changes. And the moment the message is placed on data queue from IBMI side, it will immediately be pushed to Kafka topic. And then obviously, there are many different things that can be done with that message. In this case, we can configure a very simple JDBC sync connector that pulls the data from this topic, and connects to this RDS instance of MySQL. We do implement absurd here, so for new records, they will be inserted. And if the record already exists based on the key, it will just be updated with the information. And here's the target table name. So simple configuration, both for source and sink, and in a few minutes or hours, maybe with testing, you're getting an end-to-end replication solution that works without a single line of code. Back to you, Ryan.
Thank you for your time watching this demonstration. If you have any questions or would like to get in contact, our phone number and email are on the screen. You can visit our website at www.infoviewsystems.com or check out our information in the description below.